This is 5.5 part 2, looking at the rational zeros theorem first. So before we do that, think about what we did in part 1, the very last problem right here, number 9. What we were doing was we were factoring a polynomial that formerly you could not have factored by grouping or by any other method that you've learned. But by knowing one of the zeros, which was -5, and then dividing that out using synthetic division, we were left with a polynomial that we could then factor. Hence being able to factor the polynomial completely right here. And so that's just that's your new tool. You can factor more polynomials using synthetic division to divide out factors. The problem is, here on number 9, you were given one of the zeros. Now, obviously, you're not always going to be just given one of the zeros or one of the factors. That would eliminate the whole purpose of being able to factor this polynomial using synthetic division, right? If you're having to be told what one of the factors is in the first place. So today we're going to look at how you can figure out what one of the factors are, so you don't have to be told. And that comes from the rational zeros theorem. So here's what it says. It says if P over Q is a rational number, so a fraction or a whole number, right? Because I could even have like, I can even have like 5 over 1. 5 over 1 would be a rational number. So whole number, fraction, that's a rational number, written in lowest terms. And if P over Q is a 0 of f, a polynomial function with integer coefficients. Okay, so you have a polynomial, and they're saying P over Q is a 0 of f. Then P is a factor of the constant term, which is that last number when it's in standard form, 15 right here. And Q is a factor of the leading coefficient. Okay, so what that just said was that any rational factor, so that's going to be a real number, that is a rational number, that is a factor or a zero, that is a 0 of this polynomial, has to be written in the form P over Q, where P is going to be a factor of 15, so 1, 5, 3, and then Q has to be a factor of 2. Okay, in order for a number to be a 0, a real 0 of this polynomial, a rational 0 of this polynomial, it has to have a numerator that's a factor of 15 and a denominator that is a factor of 2. Okay, so let's run through that with this example. All right, so we're saying we've got our P's. I like to do it this way. My P's are going to be factors of 15. Okay, so that's going to be 1, 3, 5, and 15. And then my Q's are going to be factors of 2. Okay, so that's 1 and 2. Okay, and then you get your list of potential zeros. Your list of potential zeros is going to be all of the combinations of P divided by Q. And to make it a little more fun, it's actually going to be all of those positives or negatives, right? It could be a positive fraction or a negative. So let's get all of our combinations out. It might be easiest first to just divide all of your p's by 1. Okay, so I've got 1 over 1 is 1, 3 over 1 is 3, 5 over 1 is 5, 15 over 1 is 15. Okay, so there's my whole numbers. Okay, and then I'll do all of them divided by 2. So 1, take my p equals 1 over my q equals 2. So 1 over 2 is a potential 0. Then I've got 3 over 2. Then I've got 5 over 2. Then I've got 15 over 2. Now you might have some that repeat later on, and if they do repeat, you don't need to write them twice. Like if the fraction reduces to another fraction that you already have written, you don't need to repeat that. Now any of these can be positive or negative. So positive or negative 1, positive or negative 3, positive or negative 5, and so on. Now that might seem like a really long list of potential zeros, but just think, before you had done this, there were infinitely many potential zeros. Now you have it narrowed down to this list of 1, 2, 3, 4, 5, 6, 7, 8, 16. You have 16 potential zeros. And actually any rational zero of f of x is contained in this list. Okay, so these are all potential rational zeros. Of f of x. And now that also helps you, because if those are zeros, again, you can get the factor, right? You can get the factor of f of x from that. All right, let's see how this can be applied to factor a polynomial completely. So you've got your polynomial here, and it says to use the rational zero theorem to factor the given polynomial. First, you want to list the possible rational zeros using the rational zeros theorem, just like we just did. Okay, so your p's, again, are the factors of the constant term. So 1, 2, and 4. Your q's are the factors of the leading coefficient. So that is 1, 2, 4, and 8. Now you get your list of plus or minus p divided by q. So I'll have plus or minus 1, plus or minus 2, plus or minus 4, just dividing all 3 of my p's by 1. Okay, now I'm going to divide them all by 2, plus or minus 1/2, plus or minus 1, right? If I do 2 divided by 2, so I don't need to write that again. And then I have plus or minus 4 over 2, which again is 2, so I already have that one. Now I'm going to divide them all by 4, plus or minus 1 over 4. 2 over 4 reduces to 1/2, I already have that. 4 over 4 reduces to 1, I already have that. So plus or minus 1 over 8. 2 over 8 reduces to 1 over 4, already have that. 4 over 8 reduces to 1 over 2, already have that. Okay, so that's my complete list there. That's my list of possible rational zeros. Now, find all rational zeros and factor f of x into linear factors. So the way you want to do this is by starting with your list of potential zeros and performing synthetic division, just kind of going down the list. You can guess which one you think might actually work, or you can just start at the beginning of your list, like I'm going to do here. I'm just going to start with 1. 1 is easy. Now you're going to do synthetic division to check to see if 1 is a 0 of your polynomial. And remember, that means you're looking to see if the remainder is 0, right? If the remainder is 0, 1 is a 0. So let's do this. Probably need to have my calculator out, huh? For some of these. This doesn't look like it's going to work out. Yeah. Okay, so 1 is not a 0. Now we'll try -1. It's kind of a little guessing game, but now that we're very proficient with synthetic division, no problem. It's pretty quick. All right, so this one gives us a remainder of 0. So it looks like -1 is going to be one of the zeros, which means x plus 1 is one of the factors. Okay, so you've got this whole solution there. You've got -1 is one of the zeros, x plus 1 is one of the factors. Okay, let's see what else we can find. So this new polynomial, you could check to see if it's factorable. Remember, the degree is going to go down by 1. So this is going to start with x cubed, 8x cubed minus 34x squared plus 7x plus 4. Now, if you could factor that, you are certainly welcome to, but that one looks to me like it's not factorable, so we are going to just keep going. We're going to use these as our new numbers, our new coefficients, instead of the old original coefficients. So we've got 8, -34, 7, and 4. And now I'm going to try my next number. You actually could start over and try 1 again and try -1 again, because actually, sorry, not 1, because that's obviously not a factor, but -1 could be a factor with multiplicity 2, so you could check that again, theoretically. So I'm going to keep going down the list, and then maybe if I run out of options, I'll come back to it. So I've got 8 to 16, -34 plus 16, -18, -36, that's -29. That's definitely not going to work out. Okay, so we'll try -2. I know this seems tedious, but it is what it is. So 8, -16, that's -50, positive 100, definitely not going to work out. Here, no, that's definitely not going to work out. So we will try, let's see what's next on our list. So we don't need to do 3, right? Because that's not on our list here. So we're going to go to +4. So we've got 8, -34, 7, and 4. Again, those just coming from our new coefficients after dividing out x plus 1. This one's looking promising. And we've got another remainder of 0. Perfect. So it looks like x minus 4 is one of your factors, and 4 is one of the zeros. So now let's just take the polynomial that we have created after dividing out x plus 1 and x minus 4. These are our new coefficients. That is 8x squared minus 2x minus 1. Okay, now we could try to factor this. That's what we should do next instead of continuing down our list. So 8 times -1 is -8. Two numbers that add to -2 and multiply to -8. We can do 4 and 2, make the 4 negative. Okay, factoring by grouping here. Okay, so I've got my matching binomial 2x minus 1, and my leftover 4x plus 1. All right, so those are my other two factors. I'm a little bit out of space here, as you can tell, but we'll make it work. All right, so I was supposed to find all of the rational zeros and factor it into its linear factors. I'm going to start by writing out the factors of f of x. So taking all of the factors that we have found, so x plus 1, x minus 4, and then these two that we got here by factoring. So that's x plus 1, x minus 4, 2x minus 1, and then I'm out of space. Ooh. Still out of space, 4x plus 1. Okay, so that is my linear factorization. I have factored that polynomial completely, and all of my factors are linear, meaning there's no x squared or x cubed in any of my factors. Now to get the zeros, well, we've still got -1 and 4, right? And that is coming from both of these factors. So x equals -1 from the x plus 1, 4 from the x minus 4. Now for the other two, you would set the factors equal to 0 and solve for x. So x equals 1/2, which is on our list up here. We could have gotten it if we had kept going. And then my 4x plus 1 equals 0 gives me x equals -1/4, which again is on our list up here. Okay, so those are the zeros. All right. Let's do another one of those. And then we'll stop. So we're going to do one more like that, and then we will stop for part 2. List all the possible rational zeros using the rational zero theorem. So my p's are going to be my factors of -8. My q's are going to be my factors of 1. So that one's nice and easy, actually. So my p over q's, my plus or minus p over q's, so I don't forget that I can have positive or negative, are just going to be plus or minus 1, 2, 4, and 8. Okay, so actually only 8 options to check this time. All right, let's test them out. So list out your coefficients. I'm going to put my positive 1 in the box first. Got lucky on this one. The first one actually worked. So remember, this is your remainder, which means 1 is a 0, which means x minus 1 is a factor. All right, so we're going to take our new coefficients and we'll try, actually from there, since we've already found one, and since there's only 3 numbers left here, that means this is a quadratic. And we can factor that. We know how to factor quadratics. if you couldn't factor it, you could always plug it into the quadratic formula once you get to a quadratic, or use any other method that you've learned this year. Okay, so two numbers that multiply to 8 and add to 6, 4 and 2, positive 4 and 2. So it's going to be x plus 4, x plus 2. Because there's no coefficient in front of the x squared, or because the coefficient is 1 in front of x squared, you don't have to factor by grouping or do anything else. So x plus 4, x plus 2 are your other two factors. So this one was much easier. Your factors are x minus 1 from that first 0 that we found, x plus 4, x plus 2. Okay, and then that means your zeros are 1, negative 4, and negative 2. Nice and easy on that one. All right, that's it for part 2.